Last but not least, we are now on passage 7 of ACT 70A. Now, passage 7 deals with two different experiments that were done dealing with calcium carbonate. Number 35 reads, a 0.05 gram sample of powdered seashell was tested as in experiment 2. So we know we're going to be looking at experiment 2. The calcium carbonate content was calculated to be 81%. Based on figure 2 and table 1, the change in pressure for the seashell sample was most likely blank. Now again, remember, with these science passages, you've heard me say it before, you always want to find the clues that will tell you exactly where to look. In this case, figure 2 and table 1. Now remember, the question explained that our powdered seashell had a calcium carbonate content approximately at 81%. Now when we compare it to these guys over here in table 1, we see that we don't necessarily have anything that was at 81%. However, eggshell was at 87%, so we know it'll probably be in that area. We can also see a trend that as the calcium carbonate percentage increases, so does the change in pressure. That being said, at 87%, we saw a change in pressure at 25.5. And when we look at our answers, we see that letter C is between 21 and 26, which would fall into that range that we're looking for, and again, because it was really close to our eggshell. Number 36. If an additional trial had been done in experiment 1, so we know where we're looking, in which 0.06 grams of calcium carbonate had been tested, the change in pressure would most likely have been, now if we jump to figure 2, we see a nice graph that gives us exactly that information for the trials that were run, 0 through 0.05. Now remember, the question was asking us to predict at 0.06 what the change in pressure would be, and we see this upward trend. So if we just kind of follow that line out, we'd see that it would probably be somewhere in the 30 to 35 range. So when we compare that to our 4 potential answers, we see that letter G gives us exactly what we're looking for, between that 30 to 40 change in pressure. Number 37. A student claimed that in experiment 1, increasing the amount of carbon calcium of our CaCO3 that was added to the acid solution increased the reaction rate. So it asked, does figure 1 support this claim? So you guessed it, we're going to go to figure 1. Now when we look at figure 1, we could see that each of our experiments spiked relatively quickly in the first 2 seconds. However, when we had our larger amount of our calcium carbonate, we see that it spiked and then peaked very quickly. Whereas with our lesser amounts, although they spiked, they still continued to grow for a little while. All the way down here, you see that with 0.1 or 0.01 grams, it took all the way to about 8 seconds before it finally peaked. So that being said, when we read through our 4 possible answers, we would see that A does the best job of describing it. It says that yes, because the time to reach the maximum pressure was shorter in the trial for 0.05 grams than it was in the trial for 0.01 grams. Okay, number 38. Which of the following assumptions must be made to properly interpret the results from experiment 2? So again, we know where we're looking. Now, when we look at experiment 2, it says right off the bat, students use the procedure from experiment 1 to test our samples. Now, if we look back at experiment 1, we could see that they stopped their timing at 14 seconds. But that was also when we were dealing solely with our calcium carbonate. When we look at experiment 2, we see we have a number of different substances with various percentages of our CaCO3. So who knows if they would stop at 14 seconds. That being said, if we read through our 4 potential answers, letter G is the one that stands out. In each trial, the assumption we would make is that the pressure stopped increasing by 14 seconds. Number 39. Which of the following assumptions was made about each substance tested in experiment 2? Again, clue, experiment 2, and again we're looking for an assumption. Now when we take a closer look at our results from experiment 2, we see that the only things we see is our change in pressure, and also with each of these substances, what percentage of them were made up of our calcium carbonate. So that's kind of what we're assuming, that it's really the calcium carbonate that is causing this change of pressure. So as we look through our 4 possible answers, letter B touches exactly on that we had an assumption that calcium carbonate was the only component of the substance that would react in the acid solution to produce the gas. Because who knows, those other percentages of the substances could have reacted as well and contributed to the change in the rate. Last but not least, number 40. Suppose 1 gram of supplement B were mixed with 1 gram of eggshell to form a homogeneous powder X, and then 1 gram of antacid C and 1 gram of cement were mixed to make our powder Y. Based on table 1, so we know where we're looking, if powders X and Y were to be tested as in experiment 2, which powder would have the highest percentage or change in pressure? Now when we look at those combined, right, we said that our antacid C mixed with cement, antacid C had a change in pressure of 11.7, cement had 7.3, so when we added those together, we get to our 19. However, with our eggshell, even though supplement B didn't really have any change in pressure, eggshell had quite the change at 25.5. So we see our 2 results over here. So that being said, we could say that F would be our answer, powder X, because powder X would have the higher concentration of our carbon, of our CaCO3. So that was our tutorial for ACT 70A. I hope you found it to be helpful. Feel free to go through it again, and best of luck with the ACT.